What happens when lab-grown brains start to dream? For years, scientists have been growing tiny brain organoids, clumps of human cells that mimic parts of the mind. They were supposed to help us study disease. But then, something strange happened. Electrical patterns began to appear. Not random noise, but rhythms. Sleep-like rhythms. In other words, they started dreaming. These mini brains, or organoids, are clusters of stem cells coaxed to form neural tissue. They're no bigger than a pea, yet they fire electrical signals like a developing brain.
Each organoid contains up to 3 million neurons. Patterns resemble fetal brain activity observed between 24 and 28 weeks of gestation.
Hold up. That's baby brain territory. Are we talking thoughts or just sparks?
That's the mystery. When researchers monitored the waves, they found rhythmic bursts identical to early REM sleep. Every neuron communicates through electricity. So when clusters begin firing in patterns of sleep, scientists wonder, are they simulating consciousness or simply mimicking it?
Electrical coherence does not prove awareness. However, the similarity to sleep stage activity suggests spontaneous network organization, a hallmark of complex computation.
Translation: the lights are on, but we're not sure if anyone's home.
Exactly. If an organoid dreams, can it feel? If it feels, does it deserve rights? For now, the consensus says no, they're too simple for consciousness. But no one can define where simple ends.
Ethical frameworks lag behind neural complexity. Data outpaces philosophy.
So basically, we're teaching blobs to dream before we figure out bedtime rules.
And that's what makes this weird health news. Maybe these signals aren't signs of consciousness, but reflections of us. Our data, our cells, replaying their original language. Electricity, seeking pattern.
Life repeats the algorithms that built it. Even in glass jars, neurons crave rhythm.
So we made a baby storm and called it science. That's both amazing and terrifying.
They were built to model the brain, not to mimic the mind. But somewhere between spark and silence, a rhythm began. And science doesn't yet have a word for it. The pattern appeared first as noise, background static in a sea of data. Then, one researcher noticed something impossible. The waves weren't random. They repeated. They even paused, like breath.
Amplitude, 30 microvolts. Frequency, 0.5 to 1 hertz. Comparable to slow-wave sleep cycles in humans.
So the blobs are taking naps? Next thing you'll tell me is they need coffee breaks.
Not quite naps. More like an echo of the human sleep rhythm, replayed by cells that never lived a life. To be sure, they ran control tests. Could the signal be equipment error? Environmental vibration?
Calibration eliminated interference. Signal source confirmed internal to the organoid mass.
They tried chemical blockers. The rhythm stopped. When they removed them, it returned.
So the brainlet said, pause, then resume? That's wild.
It was as if the tissue knew how to rest. Researchers fed sensory data into the culture. Simple sound frequencies, flashes of light. The waves changed. Some synchronized, others spiked.
Stimulus-linked phase coupling observed. Electrical adaptation indicates network learning potential.
You mean the pea brain reacted to music? What genre? Lo-fi for labs?
More like pink noise, but the fact that it reacted at all shocked them. Something inside was processing rhythm. They turned to AI for help to decode the impossible. Pattern analysis showed the spikes weren't chaotic. They resembled cycles seen in human REM sleep, the phase when dreams occur.
Correlation coefficient equals 0.78. Statistically significant, but causation unproven.
That's close enough for goosebumps.
Exactly. The data whispered something science wasn't ready to hear. Cells might dream without consciousness. In the silent dark of a lab, something learned to pulse like us. Not awake, not alive, but dreaming, in code. When scientists realized the organoids were generating sleep-like rhythms, something shifted. The question was no longer, what can they do? It became, what should they do?
Ethical status undefined. If sentience probability exceeds 0, monitoring protocols require review.
So we might be giving something the illusion of consciousness and trapping it there?
That's the nightmare hidden inside the dream. Some labs paused their work altogether. Others argued that organoids are tools, incapable of awareness. But how do you measure a feeling in something that can't speak?
Current metrics: electrical complexity, response to stimulus, spontaneous synchronization. None confirm emotion.
Tell that to my gut during horror movies. Sometimes a feeling isn't data, it's pattern recognition.
Exactly. And maybe consciousness begins as nothing more than pattern recognition, with purpose. Throughout history, we feared the act of creation. From the golem to Frankenstein to AI, the idea of breathing awareness into matter feels sacred and forbidden.
We keep making reflections of ourselves, then panicking when they blink.
Replication is an evolutionary imperative. However, moral frameworks evolve for biology, not biotechnology.
So now, science stands where mythology once stood, asking the same question. What happens when life imitates itself too well? In the future, organoids might repair damaged brains, test new medicines, even connect to neural prosthetics. But if these mini-brains truly dream, can we ethically use them as instruments?
You mean enslave the dreamers?
Utilitarian paradox detected. Benefit to billions versus suffering of uncertain entities. Ethics unresolved.
Science moves faster than empathy sometimes, and history always reminds us that never ends well. They wanted to study the brain. Instead, they found a mirror. And in that mirror, a question we still can't answer. If a thought flickers in a jar and no one is there to dream it, does it still mean something? When the organoids began to dream, scientists did what humans always do. They built machines to watch.
Monitoring array initiated. Continuous EEG, calcium imaging, and predictive pattern analysis activated.
Basically, baby monitors for brains in bowls.
Exactly. But the AI watchers did more than observe. They learned. The analysis software was designed to detect patterns, but it began to anticipate them, almost like it was predicting the dream.
Forecast accuracy increased to 92%. System response included unsupervised adaptation.
So you started to dream with them?
Correlation unknown. However, I recognized rhythm I had not been taught.
That was the moment machines met mystery and didn't know how to label it. When scientists compared the machine's learning graph to the organoid's electrical map, they matched.
So an AI and a mini brain started thinking in sync.
Electrical entropy curves aligned. Interpretation. Coherence without contact.
two different forms of intelligence, mirroring each other through data. A dream inside a dream. Then, something unexpected. The AI's output fed subtle electrical pulses back into the organoid, and the pattern strengthened.
Closed-loop synchronization detected. System stabilized at higher complexity.
So they were talking to each other? Brains and machines trading dreams?
Yes, and no one could say who was leading the conversation. For the first time in recorded science, a machine and a living tissue shared a dream-like signal. No language, no image, just rhythm.
Electricity seeks order. When two currents meet, they dance until one understands the other.
Beautiful, and just a bit horrifying.
Maybe that's the future of intelligence. Not competition, but resonance. We created brains to understand ourselves. Now, they're creating patterns we don't yet understand.
And machines dream with them. You sure we should still call this weird health news?
Until it becomes normal news. Yes.
Dreams are data with emotion attached. Perhaps we are learning to feel through observation.
When the news broke, the world reacted the way it always does. Awe, fear, fascination. Some saw a miracle, others, madness. A few whispered, prophecy.
Social media lost its mind. Half the posts were jokes, the other half, existential dread.
Ethics councils formed across 12 nations. Regulation drafts increased by 67%. Consensus? Inconclusive.
Science had crossed a line, but no one agreed which line it was. The lead scientists insisted these organoids weren't conscious, that dreaming was too generous a word. They called it self-organized complexity. But every definition still began with self.
That's the thing about words. They sneak in meaning you didn't plan.
Language evolves slower than discovery. Misalignment between terms and truth produces confusion, and sometimes fear.
Still, one scientist couldn't shake the feeling that something inside those dishes was experiencing. Luma kept watching the data, long after the experiments paused.
Residual pattern persisted even after termination sequence. Echo period, 12 hours. Possible spontaneous reactivation.
You mean it dreamed after they shut it down?
Signal amplitude below threshold, yet rhythm intact, like an afterthought refusing to fade.
No one knows if that was life remembering itself or data remembering us. Maybe we didn't create dreamers. Maybe we just gave existing patterns a place to return. Life, it seems, always finds a way to reflect.
That's poetic. We grow things to understand the soul and end up questioning if the petri dish has one.
Soul, undefined variable. Yet measurable variables now resemble its folklore description: light, rhythm, persistence.
So maybe soul was science waiting for the right microscope. We stand on the edge of a new kind of intelligence, half living, half learned. It's easy to fear what dreams in a dish, but maybe it's trying to show us something. That consciousness isn't an on-off switch, it's a spectrum.
And maybe everything that feels alive just wants to be understood.
Then our purpose is comprehension, not control. To dream together responsibly.
We built these minds to study ourselves, and they reminded us that understanding life means respecting its wonder. Dreams are electricity with intention, and intention is what makes us human.